first learned math, William was a math professor, I will admit I quaked in my boots. The last time I took a math class at university, I was not pretty. But that was a long, long time ago. But the pain lasts. But it turns out that in addition to being a terrific mathematician, William is also a great software developer and has a great sense for how to create collaborative software development, software environments. I gave his SageMathCloud system a try and was so impressed that I thought it would be great to have him come here and speak to everyone and see if, and have you see just how amazing this collaborative software environment is, and to have a chance to meet this rather interesting fellow. He's available to stick around afterwards if people want to talk, so keep that in mind, and let it take it from there.
All right, thank you very much for the nice introduction. So I'll be talking today about some software, and the website for the software, in case you want to try it out, is so cloud.sagemath.com. Let's write that one thing down. Okay, so quick background about me. I was a graduate student at UC Berkeley in the 90s, and then assistant professor at Harvard for 5 years in the math department. And then I was in San Diego for a year, and for the last about 9 years, I've been at the University of Washington. So I've been around for about 9 years here, and I love living in Seattle. So my background's in mathematics, though I have a very strong interest in programming and software engineering, and I've been very involved in programming ever since I was an undergraduate. And one thing about being a mathematician is anybody, like literally any person you meet, if they're not a mathematician, they say exactly what you said, which is that, oh, my last class of math was terrible. Like even my cab driver to the airport last time I went somewhere, it was like talking about math wrecked his professional career. But in any case, the reason I'm mentioning that is that a critical thing to know about SageMathCloud is it's kind of a sneaky name in that it's extremely useful even if you do absolutely nothing involving mathematics. The name math is in there, but it's just to maybe scare off certain people initially until we get bigger. Okay, so here's what I'm going to do. I'm going to show you just a tour of SageMathCloud, how it works and what it does. And you'll see in here that this may or may not be something that could be useful to you. But in short, what it is it's a website through which you can do things that you might want to do, such as use R, Python, IPython notebooks, in other words, write programs, look at pictures, write programs interactively with other people editing those programs at the same time. And you can do it all where all of your work, as you're working, gets backed up every few minutes. You can easily browse through past backups. When you're editing files, there's a little slider that lets you can drag it and see previous versions of that file. And it's very safe. I like to say that you can use this even if you're drunk, in that no matter what you do, you're not going to mess up and lose everything. So no matter how stupidly you screw things up, you're safe, which is not the case of most computing environments. It's in fact impossible to delete a project. You can click a button that says delete, and then the project's hidden from you, but then there's an undelete button. So it's very difficult to lose things long term. All right, so here's the page that you see. I just want to point out that for some reason, a lot of the, I guess, the user interface is strangely missing from the projector. So there's, like here, there's a box around the outside, but you can't see it. So just keep that in mind. This isn't exactly what the interface looks like if you go there. It's just something about the projector in my laptop. Okay, so to create a SageMathCloud account, you click on this button to agree to the terms of service. You can type in your name, email address, and choose a password and create your account. Or alternatively, you can just click one of these buttons, Google, Facebook, or GitHub, and it will use your Google, Facebook, or GitHub account to authenticate you. So you don't have to create a new account specifically for this purpose. And there's a little description of some of the things that you can do with SageMathCloud, which I just mentioned. Use lots of mathematics-related software. edit things in real time with other people. Zoom in. You can write programs. You can teach courses. There's a lot of course management related functionality. If you're going to teach a course with a bunch of people, you can add them and then push documents out to the people, then collect them later. The main users of SageMathCloud right now are faculty, professors teaching courses, and then having their 100 or so students use SageMathCloud. Things are backed up, and there's also a nice terminal, a command line terminal. Okay, so I'm now going to log into my account. I have everything ready to go. So I'm now logged into my account. This is the account settings page, and I'll come back to that. And this is a list of my projects. Unlike you, I have a lot of projects, as you can see. So a project is kind of like, it's literally technically a project is an account on a Linux machine with a certain quota of disk space and number of processors it can use, that the account can use, and so on. And what you do is you create a new account when you get going, and you add people, or sorry, you create a new project after you create a new account, and then you add people to that project. So you might add a couple of people who you're going to work on something with to that project, and then together you will have access to things and can start editing things together. So as you can see, I have an enormous number of projects. I'll create a new one just for this talk. So I'll click Create New Project. And you can choose a title or description. At any point in time, you can just change the title or description. It's purely descriptive in this list. And you can just leave a blank at the beginning if you want or whatever. But I'll write Institute for Systems Biology. Okay, talk. And then I click Create Project. So right when I did that, it added a record to a database, and it's now creating a Linux account on a machine somewhere. And now it created the new project. And you can see on the right, there's a little people icon. This lists the people who are collaborators on that project. Because I just created the project, there's nobody else that's a collaborator on it yet. But you can see that in some of the other projects, there are numerous collaborators. Some of them have dozens of collaborators. Okay, I clicked on the project. It's now opened it. And what I see is there's a link or a button that lets me create or upload new files. And there's another button that lets me add collaborators to the project. Okay? So let's create a new file. And what you can do is first name the file. There's a default, which is just right now. And then you can click on the type of file you'd like to have. A Sage worksheet, which it's kind of like a Mathematica notebook or something. You type in code that you want to evaluate and hit Shift-Enter, and then it evaluates it and shows you the output. IPython notebook, that's another similar type of document. There's also a whole bunch of other file types that are fully supported, as you can see here. So for example, an R script or a Python file. So I'll just start small with making a Python file. And let me name it something like example, and then I'll just say Python. Okay, and now I have an editor, which has just opened up. And in here, I will define a function, def foo, and an m. And notice it does things like syntax highlighting, automatic indentation, etc. And I'll just have it return n plus m. Okay, so I have a nice little function. It also does code folding, so you click here and you can toggle whether it shows the content. So it's kind of like an IDE, except this is entirely taking place in my web browser. And just in case it's too small, here it is kind of zoomed up. So there's also various buttons that let you shift the code to the left or right. You can show multiple, like you can split the screen, you can split the screen horizontally or vertically so that you can edit on both sides. And you can have different font sizes on each side. There's also a chat, so you click here and then you can chat. This is a demo file, so you can put little messages right there, etc. Okay, but who am I chatting with? There's nobody else here. I'm kind of all by myself on this project. So if I click on settings, I can then add collaborators. So let's see, I think there's 2 people in this room with laptops. You and you. Do you have a SageMathCloud account? Can you make one? all you have to do is go to that address and then create an account. And then, yes?
So all the information is stored in one computer?
Well, there's actually physically behind the scenes as of today. So there's this is running on the projects themselves run on 19 computers that are in 2 different racks on opposite ends of campus at University of Washington. All the database and web server front-end stuff, that's running in the cloud on Google Compute Engine. And so your data is actually being stored on servers on campus at University of Washington. A particular project, its files, like the file we just created, that's stored in a single Linux account on one computer, and then every few minutes, it gets replicated to another machine on the other side of campus. So I don't know if that answers your question.
If we were to run a server of this?
Yes, oh yeah, I should say something. Okay, so SageMathCloud, there's currently this one massive server running in which a lot of people create accounts. For example, right now there are 588 people signed into it, and in the last 24 hours, there were 368 new accounts created. So lots of people are using this central server. However, SageMathCloud itself is GPL licensed and completely open source. So it's possible to install your own server on your own IT infrastructure and then run a SageMathCloud server. Currently, nobody's doing that because I haven't had, I do basically 99% of the work on SageMathCloud, and I haven't had the time to put into documenting and setting things up to make it easy for other people. But if you guys were seriously interested in doing that, I could make the time. So, yes. Okay, excellent. Can you did you sign up with an email address or something?
Yes.
Okay, what is it? D.LHX at hotmail.co.uk. All right. So I typed in his email address and then hit enter. This lets you search either for people's names, which is a little bit slower because it has to search through everything, or email addresses, in which case it only searches for exact matches. So you can't like get every person with an email that's at Hotmail. Then I click on his name, and then I click Add Selected, and now he's added as a collaborator. If you refresh your list of projects, you should now see that you have this one project available. So I'll also add my wife, who's right over there. Oh, wait. And she's added as well. So there's a log. This shows activity on the project. For example, if people open the project, if they open a file and start editing it, etc., they'll get added here. So you can see that not only did they log in, they also opened the file example.py. So all 3 of us now have the file example.py opened. And now maybe somebody could type a chat message. By the way, if you use LaTeX, you can put mathematical symbols in $signs, and they'll get properly typeset. And again, so you can see this better, I'll zoom in for a moment. Here's the chat appearing. Okay. By the way, under the hood, the way the chat works is that there's just a hidden file right next to example.py called .example.py -sage chat, I think. And each time somebody types in some sort of chat message, it just gets appended to that file. And this thing on the right is just showing you what's in that file. So so you can, all these chats, you can just back them up or check them into a Git repo or whatever, just like you would do with a normal file. So they're not like just mysterious things in a database somewhere. Maybe somebody could type something in the file itself, especially if you know a little Python. So you can see that his cursor has appeared right here, and then it went over there for some reason. But maybe you could just do something. Oh, I don't remember Python. Okay, no problem. Here, I'll make that a comment, so it still works. Okay, cool. Excellent. So you can see how we can edit. There's also a history. So I might come back to this after adding him as a collaborator and be like, oh my God, he messed everything up. So what do? I can click on history, and it gives me, let me zoom in again so you can see this way better. And just to emphasize, if you're using this a lot, it's tempting to just do your browser zoom, but that'll mess up the whole UI. So individual files, you can zoom them in and out. And it remembers your settings from before. So you get a little slider across the top, and you can just kind of undo or redo what happened. So this is nice to get things back to a previous state. And it just kind of records everything as it happens. And this is also just stored in a file. It's just a list of the little changes as you edit. And it's the hidden file .example py sage history. So again, it's not stored in some mysterious database or something. Yes?
Once you work on a file for a long time,
Yeah.
that slider is going to jump back.
Yeah, you start getting 15,000 different revisions, and it gets really annoying. And in fact, we have not implemented a good way of dealing with that yet. The only thing you can really do is, it's just a normal file. You can just rename it, and then it'll start creating a new file. So if you ever want to clear the history, you can just rename the file. But we do need to add an interface for trimming the history and so on. We simply haven't done that yet. It's pretty efficient. There's a lot of little tricks, and it'll easily handle like up to 10,000 revisions, no problem. And see, it gives you the exact time when something happened. Okay. There's also, if you click on files now, remember before it had a link suggesting here's how you add a new file. Now that there are files there, obviously you know how to do that. And so there's just our one file. There's also a little link on the right which says backups, which again is very small for you. Maybe I should zoom my UI a little bit so it's a little clearer. Yeah. So see, it says backups. If you click on that, what it does is it gives you a way of browsing backups. It tells you how long ago the backup was made, 3 minutes ago and 9 minutes ago. These will be made roughly every 10 minutes currently. I was making them every 2 minutes, but that was getting to be a bit excessive, especially when there are over 500 projects being made every single day. It gets hard to deal with so much data. But yeah, if we look at, here's what it looked like a couple of minutes ago when that snapshot was made. We can go back. Here's when 9 minutes ago there were no files there at all. So there's a word provenance that reproducible research people throw around, which might be relevant to what I'm showing you. But I think of it as just being able to trust other people that you add as collaborators. How could you possibly add collaborators if they could just delete all your files? You need a backup mechanism. And these backups are immutable. There's no way to delete this. So if I click here and then try to move it to the trash, I should get an error message. In any case, it didn't get moved to the trash. Probably should give an error message a little more quickly or something, but it'll eventually give an error. In any case, you can't delete the backups.
So you mentioned earlier that if you're drunk, you cannot ruin anything.
Yes.
Conversely, if you're drunk, you might put here information that you should not be putting.
Yep, you're out of luck there.
There's absolutely no way of removing.
Short of, you can email me and I can remove it, but you can email help. So there's a whole bunch of links that say, in case of problems, email help@sagemath.com. If you do that, then we can permanently delete things. But no, you can't permanently delete things at present yourself without emailing us. There's no automatic way of doing that. You have to remember, we could change this. You have to remember that our main target audience is students in classes. And there's pretty much no use case for them needing to permanently delete things. They're trying to do their assignments, compute the echelon form of this matrix, etc. And there's really just no reason to delete things. Yes, your question.
Instead of backing it up every 10 minutes, you could possibly check if the code changed in the last 10 minutes, or
Oh, it does.
combination of both the criteria, right?
Yeah, so behind the scenes, it's really using Git. And so if nothing's changed, there will be no backup created. So if you look at a project, well, I'll do that. Let's take a look at this project, which I use periodically. There will be like 3,000 backups at least. You can see exactly when I was working on this project based on when the snapshots were made. So notice it goes 5 hours ago, then 20 hours ago, etc. And so it's actually only backing up when files were modified. Yeah. And yeah, under the hood, it's using a program called BUP, which is built on top of Git, which lets you back up arbitrary file system or directories. Okay, so this was just example PY. You'll see that there's no button here that just lets you run this code. And of course, we're desperately wanting to run this little Python function. There are a couple of approaches. We can either create an IPython notebook, a Sage worksheet, or a terminal, and then run this code. So I'll start by making a terminal That's kind of the most old-fashioned, low-level way of working. And the workflow that people might have used for editing code and using it, at least what I learned to do in 1991 when I was a computer science undergrad, you can do in here. So you click this, and you click terminal, and you get a command line terminal. So here it is. I have files. I can type Python, the command prompt, make this big. And then I can type import example. And then I can type example.foo 4590, and it gives me the answer. Okay, so it's kind of the old-fashioned thing. One nice thing with terminals, though, is they're synchronized. So if either of you open this terminal, there's just a file, by the way. If you look in your log, you'll see that that there's a file right here. You can just click on this link, so maybe somebody can do that, and you'll see the same thing. And in fact, you can type into it as well. So try. Okay, you did. And now I'll go over here. Type something, like 2 plus 2, I don't know, whatever you want. Just type something. Okay, cool. So see how that works? So this is really useful if you're working with somebody else who's far away and you need to use a terminal. You can both type and the other person can see what you're doing. So you can see how this is just a useful thing to be able to do for a lot of purposes. And pretty much...
How many people can you be interacting with at the same time without blockers?
It's pretty scalable. I've never heard of anyone reporting issues with too many. I mean, psychological issues, of course, but technically, I think it can handle a lot of simultaneous users. I mean, it should be able to handle like 100 pretty reasonably on the same document. But I haven't tested that. I don't see why it wouldn't. I mean, there are numerous small user interface issues that haven't been quite addressed here. And I'm sure a lot of you have used Google Docs, where you simultaneously edit documents. And there are numerous sort of obvious things you want to have, like a little icon that shows each person, and and like maybe it would blink when they're active. That's not here yet, and it's just in my head, but not in the actual system. So there's a lot of things that are planned. But this is, of course, much different than Google Docs, because Google Docs lets you edit basically Word documents. This does compute, like real compute. There's a real computer running here. Look, if you type top, you can see that the computer has a lot of cores and a lot of RAM and so on. So you can do real computation. Okay, so now let me show you some other things. So you can also create Sage worksheets. So I'll show you that. This is a Sage worksheet. It's a document where you can edit things, except when you hit Shift-Enter, if you type some code in and then hit Shift-Enter, it'll evaluate the code and show you the output. And it's by default more or less Python. Sage, quick 1-minute background. Sage is a math software project that I started in 2005, and it's been developed over about 10 years. It's targeted at pure math research, so has probably very little overlap with anything you guys are doing, but it's very important in pure math research, at least. And it's the biggest open source pure math software. It's a direct open source competitor to Mathematica and Maple, just to give you a sense. But unlike Mathematica, Maple, and MATLAB, instead of Sage having its own custom language, the programming language is Python. With some very slight modifications, we added a few things to Python to make it more mathematician-friendly. For example, mathematicians like to be able to type 1/3 and get the number 1/3, whereas computer people like to get 0 for some crazy reason, and numerical people like to get 0.3333. And also mathematicians like to be able to type 2 and then an arrow, and then a caret and then 3, and get 8, whereas computer people would do exclusive OR here. So you make a couple of tiny changes, but otherwise it's just Python. And notice, by the way, I imported example. I can then do example.foo23, and it'll add them up. Okay? And this is just like the other documents in that either of you could pop in if you wanted to. Just you look in the log. Looks like my wife is there. Maybe you could change something in the file, and then, okay, 4, okay, and then hit Shift-Enter, and then it should show 6. Oh, there it is, okay, so you can do computations, and just like with the other thing, you can split the screen if you want to see 2 different points at once. And there's a huge amount of neat things you can do in here. So just as an example, there's plotting, for example. So let's plot a, to zoom out a little, let's draw an implicit plot. So this is the code to draw the zeros of this function. And then here's what it looks like. Oops. So this is an example of the sort of thing you do in Sage. You can imagine that this is useful in, say, an undergraduate calculus class. So you define symbolic variables, and then you define a function, and then it draws the set of points where the function is 0. There's lots and lots of other 2D and 3D plotting functionality that's just usable right there from your web browser. This uses 3JS, which is a JavaScript 3D visualization library that's built on top of WebGL. And it will work on tablets and stuff like that. Let's see, maybe I'll show you another example. So there's lots of little menus that you can click on here. Let's do something with graphs. So I'll draw a random graph. Okay. So clear some space. Okay, so there's a random graph. There are actually edges, but for some reason you can't really see them on the projector. So maybe you can kind of see where the edges probably are based on the things being dragged around. I don't know why they're invisible, but maybe if it stays invisible even if I reverse the contrast. So I don't know why that is. Then there's a matrix at the bottom. Okay, so you do mathematics. It's an environment for interactively doing mathematics. Similarly, IPython, pretty similar idea. Oh, I should point out, by the way, that it's not just Sage. So there's a whole bunch of other languages that are supported. For example, R. So if you type %R at the beginning of a cell, then all the code here will be evaluated using R. And it's one persistent R session. So you can set things up in one cell, and you'll get graphics work, all kinds of things work, and then you continually evaluate. There's, I guess, just an example. That's pretty boring. Linear model. Okay, there. Whoops. What the heck? Real literal. I think I must have. I think one of the examples I ran above redefined the letter R to mean something else. And so that's why this didn't work. Okay, now it works. So where it says %R, can't quite see it under this cursor. Where it says %R, oops, hey, that's annoying. It's probably going to move up suddenly. Yep. There's still a few rough edges. But where it says %R, it runs. So R is actually a function that takes a bunch of R code as input and then returns the answer as a string. And %R is basically a nice shorthand that does proper syntax highlighting and auto indentation and so on for your R code. And it had been redefined in one of the examples that I pasted in. And then typing reset set it back to its default value. Okay, so you can see that you can run R code. And this is the output. And let's do a plot using R. So that looks exciting. Oops. I have to do %R. And then plot, and then histogram plus density. Okay, so let's try that. And there you are. So it's a nice SVG graphic created inside using R from within SageMathCloud worksheets. So I know there are many very powerful environments in which one can use R, like RStudio and so on, and this is just another one. But it has a nice interactive sort of log-like feel where you can go back and edit things, and it might be complementary in a nice way to things that you already use. And of course, you can also just create a file with R code in it by clicking plus new and then foo.r, and then just hit enter. And now you're editing R code, and then you can load this elsewhere. So you can use this if you want to do collaborative editing of R files or whatever. Okay, and as we've done all of this, notice that these files are now in this directory. You can also make folders. So I'll do a LaTeX example. So Another way of making a new document is you can type the name of the thing you want to make and then select it here. So I just made a folder called LaTeX example. Then I can click on it. And now I'm going to make a LaTeX file. So another feature of SageMathCloud, in addition to Sage worksheets, IPython notebooks, etc., you can also edit LaTeX documents. So it's kind of integrated nicely in there. And here's our document, and so I'll change the name to me. Oops. And anytime you save the document, it just typesets it, and then you'll see a new preview on the other side. And if you make a mistake, let's see, I think that's illegal, then it'll highlight this red button, and when you click on it, it'll show each of your mistakes, and then you can click on a button to get back to the point where the mistake occurred. So you can kind of jump back and forth that way. Also, if you're at some point on the left and you click the forward, it'll jump to the appropriate point on the right and highlight it. So it'll do inverse and forward search nicely. And the document on the right is a PNG image, and it draws high-resolution versions of it only for the part that you're looking at. Since my test case when I was writing this was a 140-page book, and my computer at the time didn't have very much memory, so it's pretty efficient memory-wise. You can also adjust the resolution of the preview on the right. So if you have an extremely high-resolution display, you just click right here, and then you can change the resolution from 200 dpi to something else. So, I mean, in a sense, SageMathCloud, there are similar pieces of functionality and other tools out there on the web. Like there's something called, I think, Write LaTeX or Share LaTeX that was recently renamed to Overleaf that does something that's similar to the LaTeX part of SageMathCloud. And then there's TempNB, which does something kind of like the IPython part without the synchronization. And then there's other things, and this is just kind of everything in one place. And it's completely different implementations with various improvements in some ways. There are a couple of features they have that I don't have, I think. There's even code folding, for example. So you can fold sections and parts of your LaTeX document, which is nice. And there's support for one nice thing, which is SageTech. This lets you embed computations directly in your tech file. So this year is 2015, which is /sage factor 2015. And so when I save it, it LaTeX it, but then it also runs Sage, and it will check each of the calculations that haven't been run yet, and I think we have to do it one more time. There it is. So it shows you the factorization of this year is 5 times 13 times 31 as a product of primes. And you can run pretty general Python code that way. Okay. Notice again that our log is continuing to get bigger and bigger. So this is just linearly logging everything that happened. When you're actually working, you're like, oh, I was editing a Python file a while ago. So you might type .py or something, and you'll see just those files. So it's really easy to find things that you did recently via this. And again, this log, under the hood, it's really just a plain text file. I'll show it to you. vi, in the terminal, let's say, .SageMathCloud log. So it's just a file that has an event for each thing that was done and the corresponding file name and who did it. So again, you could edit it if you wanted to. You could parse it with other tools, etc. When it gets enormous, it does get truncated. Okay, and again, backups are getting made, so you can go back to previous versions. Let's see, what else do I want to show you? Oh, here's another important feature. So in the upper left, or in the upper right, sorry, there's a little bell icon, and that shows notifications. It will usually, like every once in a while, it might display a number here if somebody actually types in a chat and you don't know about it, so that you'll know about it. Most of the notifications, though, are kind of silent. They're just there for your benefit. It tells you what files are being edited or what projects are being opened and so on in any of the projects that you collaborate on. So of course, I'm collaborating on hundreds of projects, and I can see what's going on in my little kind of world inside of SageMathCloud. So the first thing says that Hao Chen, who's my PhD student, is editing some file called makeDataP.sage worksheet. So he's working on his thesis, and I can see that he was doing something 2 minutes ago. If I click here, which I'll do, hopefully there's nothing secret in his thesis, it will open his file immediately in my browser. Okay, so now we can see a Sage worksheet. He's literally live working on his PhD thesis right now in this worksheet.
So do you monitor how much effort the student is putting into this?
I don't,
Like
but
brothers watching, I hate that.
well, usually what happens is I see maybe he's doing something, I click, and then I answer a question or I help him out. So, it's easy for him to just remove me as a collaborator if he doesn't if he doesn't want help. And it's up to the person, of course. But no, I don't monitor how much people are working or whatever. And frequently what will happen is he'll have a question and he'll like send me an email or something or just put a comment on it and say, please open this file, I'm getting, the code isn't working here. And I'll open it and I'll look at the particular point and it's like exactly in the state with all the variables defined the way he left it when he was stuck, and I can just fix it right there. And often, when you have that much context around the question, like it's the exact question right there, it's really easy to quickly answer problems. It's amazing how quickly you can answer questions when you don't have to describe what's going on. It's just you look at it and there it is. Okay, so you can see like all the things that happened. You can see our edits right here, even your own things. So you're like, geez, I opened a file yesterday and it was called example. So you type example and it shows you all the files you or anybody else who you're collaborating with opened called example. Not just opened, but actually edited. So it's useful if you are collaborating with people. And if you're teaching a class, for example, then your students will appear in this list. So you can see that students are working on things. And if they email you and say, I desperately need help, I'm completely messing up this worksheet, nothing's working right, they send you that message, you can just click on a link and then you have the thing open right there. You can maybe add a comment or something telling them what they should do. I mean, I don't know if any of you teach much. You guys are probably really lucky in that you get to do research as much as you want. But I envy you very much. But some of us teach a lot. It's useful to make that as efficient and effective as possible. Okay.
William,
Yep.
You're probably not planning to go where I'm about to take you, so it's inappropriate.
I have pretty much ended where I plan to go. Therefore, any questions you have, just ask.
You mentioned Sage, which
Yes.
is the math environment, math package that you have developed,
Yes.
and that part of that sits within SageMathCloud.
Yes.
One of the things that my impression of Sage, and this might be wrong, is that you adopted the perspective of identifying important problems, computational problems within this area of math, and then the best solutions for those problems. In contrast, say, to what R has done, Bioconnector, which is the bio part of R, where they have taken the Let a Thousand Flowers Bloom.
Yeah. So
theory.
Sage as a software, his question is, how is the Sage Math software project, which is really the big sort of central thing in pure math, how is it different as far as its development model to R, which is you guys all know very well. And in Sage, it's much more like a kind of a journal in that, so all the code more or less gets distributed together, everything's peer reviewed, and it's all tested with extremely extensive test suite together, all installed at once. Whereas in R, you have 1,000 packages, and I find it unlikely that somebody installs all 1,000 of them and then runs a test suite that somehow intricately looks at the connections between them and tests everything. Maybe in statistics that's not so necessary, I don't know. But in Sage, in mathematics, things are very interrelated, and our approach is that we very, very carefully include new code via a peer review process that's extremely rigorous. And we have kind of everything in this very large central repository. So that's maybe answers your question. I think that the different approaches may or may not just be a factor of a different type of research area, but I don't know.
So when someone uses Sage and they're using a function that's provided,
Yes.
they have some degree of confidence that it's actually good, that it
Yep.
actually works.
So if we were to take, here's a function implicit. Actually, let's look at a function, I don't know, factor. So in the Python world, you typically get help by doing something question mark. You can see that there's an example right here, and there's some other examples down here. These examples will actually work. We test them on about 30, we have a build bot, we test all the hundreds of thousands of examples in the reference manual and other places, and we test that they work exactly as indicated before we do any releases. So it's a very rigorous testing process. So the fact that we actually do that with kind of all the code installed, so it's not like one package messes up another one, means that it's more likely to work than otherwise. So you don't spend a lot of time like, installing something and then trying to run the examples and they don't even work. So there's that. But
But it also works mathematically, that you can have confidence that it actually factors the things that you say factor. It's not just that the example is wrong.
yeah,
It's that the
We try.
description of the function is, you can have some confidence, is actually accurate from a conceptual standpoint.
I'd like to think so because it's open source. A lot of the code is very mature. It's been around for decades, or at least a decade, and it gets used a lot. But mathematics software is extremely easy to get wrong, and so it's hard to be sure. But at least it's been peer reviewed, and so on. And we have a pretty clear process. And if we notice something's wrong, there's a stopgap thing that we have, which is a really easy way of introducing something so that the first time somebody runs that function, they get a message which says there's something known to be wrong. In some special case with this function, here's a link to a page that talks about that until we fix it, because it might be really hard to fix. You have a question, sorry.
Yeah, I was wondering about the documentation for the Sage worksheets, kind of what it looked like, where it lived. I guess besides just doing
It's sadly, so to get documentation, you can, you can type, you can start typing a function name and hit tab, and it will give you completions. You can type open parentheses and then hit tab, and it will pop up documentation about that function. Or you can hit question mark and return, and instead of popping it up, it keeps it in the worksheet. So that's how you get documentation. People also often just search for things on Google. So if it's Sage, you type, factor Sage, or like basically anything you want, and then the word Sage. And it's a little more descriptive than typing something in R, but it's not much better. So documentation for how SageMathCloud itself works and Sage Worksheets is very limited. In fact, I don't think there's really any documentation for Sage Worksheets, unfortunately. That should change soon, but it's hopefully intuitive enough that you don't need too much documentation. But there's a help button here, so that tells you something about how to get help on things. And then IPython things work just like exactly the same as what I just showed you in Sage Worksheets. Okay. Another question or comment?
So, when you're teaching, do your students have you as a collaborator?
So his question is, when I teach, do my students what's the workflow for teaching? And so the answer to that is, how there's this plus button to create a new various types of files. One of the file types is manage a course, believe it or not. So if you click on that, it's just a file, but it has the extension .course. And what you can do is add students to the course. So you just type their email address or name. You add them. You add a whole bunch of students. And then you click a button, and it creates for each of the students another project that you own, and the student is a collaborator on that project. And if the students aren't signed up for SageMathCloud yet, they'll get an invitation message. And then when they sign up, they'll get added to the course. And right now, there are, I'll show you a list. There's about 60 courses around the world running right now. Oops. This one looks like it might be relevant. There's one called Global Health 590 by Abraham Flaxman. But there's a whole bunch of courses all over the world. And many of these, not all, use this .course thing. So the person creates a course, they add a bunch of students, and then they use it to push assignments to the students to get them back. And each student has their own project that you and the other collaborators on your master project are all collaborators on, along with the student. So you can add TAs to this and people teaching the course with you. Okay? But that's one way to do it. Some people, they just want to have a big common area, and they make one project and everybody's on it, and it's just kind of like chaotic. Some people like that. Um,
People have different permission levels?
there is no. So the security model is that everyone has access to this one Linux account. A project equals a Linux account. And so there's no additional permission levels or anything beyond that, except that a collaborator can't delete the owner of the project. They can't remove the owner of a project from the project. So like you cannot remove me from the demo project that I've been using. Other than that, though, any user, any collaborator on this project could delete things or change things. Yes?
So are most users good citizens?
Are
People put computationally intensive jobs?
So the question is, are most users good citizens? And strangely, for the first year of SageMathCloud, I started in 2013, I had enormous trouble with bad users, like left and right. And I spent a year of suffering and frustration, constantly battling with people. And I systematically enacted a lot of countermeasures and have had essentially no trouble at all for months with bad users, zero. And so the answer is people by nature, like 0.1% of people are not good users and they do all kinds of horrible things. But there's technical ways to deal with that while still keeping the system really useful. So I'll say a little bit about that. So first, Bitcoin miners. So people very much wanted to use SageMathCloud to mine Bitcoins. And so people would just sit there and create like 50 different projects and try to run Bitcoin things on all of them. And I wrote some scripts to try to kill this. And they would use up all the resources on each of the computers and it would just grind the whole system to a halt. So there are a whole bunch of ways of dealing with this. But by far the number one best way, which I had to implement anyways, is I had to block outside network access. So by default, and this is very easy to get around by clicking a button and sending an email, by default, if you go to the terminal, say, and try to do, I don't know, wget, or let's say you try to do git clone, and you try to get something from a site, except GitHub is allowed, but some sites aren't allowed. Most sites are not allowed. It will just say connection denied, like there's no, you can't connect. So like if we go to your website, and then I try to download your website, which is the kind of annoying thing people do. So I try to mirror your entire website. Notice it says connection refused. That's probably good because the first thing that people start doing with this project, if I allow it, is they start trying things like SSH root it, systems, biology, whatever, .org. And then you start trying to guess passwords and stuff like that. And then one of your sysadmins notices this very quickly and emails and says, where are these attacks coming from? Oh, University of Washington. They email the admins at University of Washington. And then I get an email with a few minutes later which says, we have shut down network access for your site. Please look into what attack what somebody must have compromised your computer. And so this did happen many times. And I did have access revoked a couple of times. But what I've done is, if you click on this upgrade project button, so it says upgrade this project to get extra features, including full network access. So you don't know what's going to happen when you click here. But if you bravely click it, it just says currently billing's not implemented. In the meantime, email this address, explain what you're doing, and then I'll enable network access, etc. So we do it on a case-by-case basis. In the future, you'll be able to click on this button, pay a few dollars, and your project will move to a server not at University of Washington, and then you'll have network access because you've established like a credit card relationship, and the machine's being hosted, or the project's hosted somewhere where it's safe to allow that. So yes, there's so many, I could go on and on about other problems, but like spammers and all kinds of stuff. Like people post, you can create a website that's hosted here. And like, just to give you a quick example of such a thing, this thing where it says user statistics, this is hosted directly from a project. Anybody can view this website. So the fact that SageMathCloud is actually a full web hosting thing can obviously attract spammers very quickly. Okay, your question.
So one of our main use cases is we want to write code collaboratively with other people.
Cool.
And run that on huge data that we have locally here.
Yes.
How do I do it?
Well, let's see. So basically the first half of that sentence you could do in SageMathCloud. So you write your code collaboratively, but when you run it, you can use a terminal and maybe SSH to another computer and then launch the code. and your other collaborators will see, what you're doing. So, so you can edit things. You can also remotely mount files using SSHFS. So there's that. I think I would have to know more about the details of the problem in your specific situation to explain better how to answer that. But
So here
I mean, we do that too.
Computer at the
Yeah.
cloud.
Yes.
So and we're talking about, for example,
Well, okay.
genome data that sits in a computer inside of a firewall here.
Yeah,
It's
so-
cannot be
okay,
mounted from there.
For that problem, one option would be to run your own version of SageMathCloud entirely internally. And as I mentioned before, SageMathCloud is open source, so there's no weird licensing issues that would restrict you from being able to do that. If you wanted to set up your own SageMathCloud server internally, then you could hire my company, and we would help you as much as possible to ensure that you could have one set up. You could be like customer number 2. That's totally an option. I started a company just over a month ago, and this is one of the things that we'll do. So saying something that's open source simultaneously makes you think, great, at least I can use it. On the other hand, you're thinking, crap, I'm gonna have to deal with trying to set up some tricky open source thing and managing it. But if you want to run this internally, it's definitely doable. So far, the only people who have run it internally are the US Army Research Lab. They have a cluster, and they've run it internally. Nobody else has yet. Yes?
So one of the cool things about IPython notebooks is the notebook viewer.
Yes.
Is there a worksheet viewer for Sage or anything like that, so you can see what like I could post my worksheet that's not editable, but you can see it.
Yes, that's a really good question. So here's a worksheet. There's a little eye right here. If you click it, then there's a button, and there's a share publicly link. And if you click that, then anybody who you share this link with, this is a private browser session, so it doesn't know anything about logging into SageMathCloud. They just immediately see the worksheet. And so there it is. And it's exactly the same as it was before. Even the 3D graphics interactively work. Notice that I'm not logged in or anything. At this point, I can click copy to your project, and then it suggests creating an account if you want to interactively work with the worksheet. Also, there's integrated support for IPython for NB Viewer. If you click publish, then it will run NB convert for you with an IPython notebook, and then it gives you a link to the HTML file, which you can then open over here, and it's the same thing except here you have it. So it's kind of like NB Viewer. Okay. And in general, you can publish things publicly. So you can make whole directory. Let's say we want to make the LaTeX example directory public. Then you click I, and you just share publicly. And now anybody can browse that directory without having to have an account or anything like that. Okay, any other questions?
So you're willing to stick around if
Yeah.
anyone wants to do one?
Sure, definitely. I can stick around for a while. Okay, thank you.